Hello and welcome to this video. My name is Aniruddha, Victor Uniform 3 Foxtrot Mike Lima. What a lovely day. It's about to rain. Look at those black clouds over there. The monsoon is about to start over here. What you see in front is Mahabaleshwar. So this is my place, which is surrounded by mountains. Usually there is a heavy rainfall over here during monsoons. But that shouldn't stop us from putting up an antenna and trying to make some contacts. So what I'm about to show you is a trapped end-fed half-wave antenna for 40 meter and 20 meter band. That's what I use usually. This is the famous 64:1 transformer made up of FT140-43 toroid. That you see over there is the 100 picofarad 3 kilovolt rated capacitor. The end-fed half-wave antenna is an antenna made up of this transformer and the half-wave length of wire for the band that you are trying to design. Now here in India, 40 and 20 meter band is very popular, and so I decided to make an antenna which can accommodate both these bands. And so I came up with this trapped end-fed half-wave antenna for 40 and 20 meters. So let's see how it is constructed. We have already seen the transformer. Now this section of the wire is resonant on the 20 meter band. At the end of this section is a trap. So it is nothing but a parallel circuit of an inductor and a capacitor. The capacitor is inside here. This is designed such that it is resonant at one of the frequencies, which is usually at the beginning of the band, that is 14 megahertz, and it resonates over there. So when you are transmitting in the 20 meter band, this side, that is the 20 meter element, will be used to transmit. And since this is a resonant circuit, it will act as an open circuit for the frequency range that it has been designed for, in this case the 20 meter band. So anything further to this will be invisible, since this will be open circuit in that frequency range. So when you are transmitting on 20 meter band, our system, that is the radio, will see only this section up to here. It will not see the antenna element which is attached further. Now from this point onwards is the element which makes the 40 meter band. So from the feed point all the way till here is the 20 meter element, and that previous element included, if you go further, that becomes the 40 meter element. When you are transmitting on the 40 meter band, this entire length of wire element will be considered for transmission on the 40 meter band. So what happens when you're transmitting on the 40 meter band is this will act as a loading element. Since 40 meter band, which means in the 7 megahertz range, is the lower frequency than the 20 meter band, that is a 14 megahertz frequency, this will act as inductive loading in the 40 meter band, and so the wire element, the length of wire element required from this point onwards will be required shorter. So to summarize, when you are transmitting in the 20 meter band, this element over here, which is nothing but half wave for the 20 meter band, close to 10 meters, will be used for transmission. The wire further to this trap will be invisible, and when you are transmitting on 40 meter band, the entire length of this wire element will be considered. I hope I've made it clear. I'm not giving a description of how this transformer is made. There is a lot of documentation online. This is basically 64:1. So let's put up this antenna and we will see how it measures on the nano VNA. My idea is to tie it to this column over here, and I will take it down as a sloper to one of those compound rods seen below. Let me put up this antenna and then I will come back. I hope you can see this. This is how I've attached the antenna. You see over there near the dish antenna there is the transformer, and that's the 20 meter element that goes down here. That's the trap, and then the 40 meter element goes to that chain link compound. This is the top wave. So the antenna goes down as a sloper towards southeast. I've attached a coaxial cable. I've made a few turns, 6 to 8 turns of the coax to eliminate any possible common mode currents. This may not be necessary. I've made it just as a precautionary measure. I've attached a counterpoise to the shield side of the SO239. This counterpoise is 2 meters in length. Usually you should have a counterpoise which measures 0.05 lambda of the lowest frequency that you are trying to transmit on. So I've connected the coaxial cable, and let's go and find out what is the SWR curve. This is the 40 meter band. I usually transmit on 7050, 7060, so mostly the lower side of the band. So let's see what the SWR is on the lower side of the band. Right now I am at 7060. Let's go to 7050. So I'm at 7050 and the SWR is about 1.23. So for the frequencies that I'm interested in, the SWR is about 1.2. Now let's check the 20-meter band. Okay, this is the 20-meter band, and on 20-meter band I transmit on the higher side a little bit, 14.2 and above, and for that the SWR is about 1.37, 1.38, which is perfectly acceptable to me. So I think this particular configuration of the antenna is giving good results as far as matching is concerned. So let's go ahead and make some contacts and check the performance. I hope I get some chance to operate this evening. It's very clear on this side, but over there it looks as if it's going to rain heavily. Here as well. And this is the west side. This is where the monsoon clouds come from and they pour down heavily. Let's just hope that I get some chance to operate. It doesn't look too promising, but anyways, I have operated with this antenna before, and I will put a small clip of me operating with this antenna. Let's hope that I get at least a half an hour of window to operate, but this doesn't look promising at all. I can probably sit inside and operate from there, but then I really hope that I can operate from up here because it's so beautiful outside. Well, it's the June and this is what we expect here. Anyways, I will wait for some time, and if it doesn't clear up, I will just enjoy the nature. There are some peacocks over there. VU3 Foxtrot Mike Lima Aniruddha.
Foxtrot Mike Lima Aniruddha.
VU2 Sierra Mike Sierra, VU2 Sierra Mike November. This is Victor Uniform 3 Foxtrot Mike Lima. नाही तुम्हाला 59 प्लस कॉपी करतोय, 59 प्लस 10 dB कॉपी करतोय दोघांनाही. मी फील्डमध्ये आणि अँटिना लावली आहे एंड फेड हाफ वेव्ह, ट्रॅप्ड एंड फेड हाफ वेव्ह फॉर 40 आणि 20. पावसाची लक्षणं आहेत खूप जास्त. मला सेटअप आवरून ठेवायला लागेल आणि शेडमध्ये जावं लागेल. सो फॉर द टाइम बिंग आय विल से 73 to you, 73 to both of you. Hope you are copying me. VU2 Sierra Mike Sierra, VU3 Foxtrot Mike Lima. It's about to rain. I'm just hoping that I can continue. Otherwise, I will have to end this and come back to you with a video clip that I had taken earlier. It is with the same antenna and similar setup. So I'm just going to give it a 5 to 10 minutes. If it starts pouring, I'm just going to go inside. CQ, CQ, CQ. This is Victor Uniform number 3, Foxtrot Mike Lima, calling CQ and standing by. I'm transmitting on 14.2. The earlier QSO was 7.050. I was talking in the local language, which is Marathi, and the two operators were Victor Uniform 2 Sierra Mike Sierra and Victor Uniform 2 Sierra Mike November. Both of them are old timers and very, very nice gentlemen. Victor Uniform 3 Foxtrot Mike Lima, calling and standing by. CQ20, CQ20, this is Victor Uniform number 3, Foxtrot Mike Lima, calling CQ and standing by. So I made this arrangement, usually I keep it on this, but I made this arrangement because it can rain at any moment. I just have to unplug the antenna and the power supply and lift this chair and go inside. This will save me a lot of time. The interconnections remain the same. It's about to rain. You can see it's about to rain over there, and I think I should just stop. I should just stop because it's about to rain very over there. That's rain coming towards me. Predicted it has started raining very heavily, and that's why I have to move inside, but we'll definitely make some contacts from indoors. QRZ, this is Victor Uniform number 3, Foxtrot Mike Lima.
Yeah, view to Delta Tango Delta.
View 2 Delta Tango Delta, View 3 Foxtrot Mike Lima, 59 plus here in Y, Whiskey Alpha India. Go ahead, View 2 Delta Tango Delta, View 3 Foxtrot Mike Lima.
Roger, Roger. Let us see copy from your side also on your turn. 59 plus 5 is to Chennai and Mandar, I think you recall. So now the short beam is modified further. So that is the story from this side I convey to you. View 3 FML, go ahead.
Trapped and fed half wave for 40 and 20. Trapped and fed half wave for 40 and 20.
Got it. Okay, the last time also you were using the same antenna. Okay, U3, where are they?
Again, Yankee Romeo.
Yankee Romeo Bravo.
Good evening to you, sir. View 2 Yankee Romeo Bravo. This is Victor Uniform 3 Foxtrot Mike Lima.
Victor Uniform number 3, Foxtrot Mike Lima. This is Victor Uniform number 3, not a 2, number 3. Yankee Romeo Bravo, my handle is Balaswamy, operating from South India, Pollachi, South India, Pollachi. Your report is a 59 plus, booming in my circuit.